Okay, here is another tutorial about how to do ionic equations. This time we have a solution of sodium iodide is reacting with a solution of lead to nitrate. They are being mixed together, so because this is a compound plus compound, this is a double replacement reaction. So we know that we are going to have sodium and lead switch places because metals will switch places in a double replacement reaction. So that means the products will be sodium with nitrate and lead with iodide. All right. So with that information, we are going to write out our molecular equation. Remember, with the molecular equation, you need to have all of your ionic compounds written out correctly. So that means check those charges. You need to check your solubility rules to figure out the phase of each compound. And you need to balance the reaction. So let's start. Sodium's +1, iodide's -1. So we get sodium iodide plus lead 2. That's telling you that lead is +2 and nitrate is always -1. So we have lead 2 nitrate. We have to have this 2 here to balance out those charges within lead 2 nitrate. And then we're going to make our products. The products is sodium nitrate. Sodium is still +1, nitrate is still +1. So NaNO3. Their charges balance out. Do not just take the subscript from over here, outside of nitrates, parentheses, and bring it over. You need to check the charges within each ionic compound when you're writing it. Now we have lead 2 iodide, so lead still +2, iodide still -1, PbI2. Okay, let's come up with the phases and balance. So remember, anytime there is a group 1 metal in a compound, it is aqueous. So this is aqueous, and this is aqueous. Also, anytime you have a nitrate in a compound, it is aqueous. So this is aqueous. Now our last one we have to check is our lead 2 iodide. Well, there's no group 1, there's no nitrate, and also the rule with halogens is if it's with lead, it is definitely insoluble, meaning that it forms a precipitate, a solid. Last, we have to balance. We have 2 here for iodide. We have 2 here for nitrate. So we put a 2 in front of here to fix the nitrate and a 2 in front of here to fix the iodide. We also bring along the sodiums. Everything is balanced now. So this is a molecular equation. I have the phases, it's balanced, the formulas are written correctly. Now, in order to go from the molecular equation complete ionic, anything that I've labeled as aqueous, I need to split apart into its ions. Anything that I've labeled as solid, liquid, or gas stays exactly the same. I am not going to split it apart. I am not going to change it. I'm just going to rewrite it as is. So let's start with splitting apart our sodium iodide. This coefficient is distributed to both the Na and the I. So we have 2Na plus, it is now split apart into its ions because that is the definition of something being aqueous. It dissolves in water and splits apart into its ions. It dissociates. Aqueous. Then we also have 2 iodides. That's negative, aqueous. Plus, we only have 1 lead, but it is a +2 charge. Aqueous. Lead is aqueous on the reactant side because it came in with nitrate. Now, Notice the subscript here for nitrate. We need to put it in front because it is telling us that we have 2 nitrates present. Okay, so that is just the reactants. We have taken all of the reactants and we have taken our aqueous compounds, splitting them apart into their ions with their charges, with their phases, still balanced. Now our products. Notice the 2 is going to get distributed to both the Na and the NO3. It's aqueous, so I split it apart into its ions. And I ran out of room, so I'm going to put the lead iodide solid at the bottom. I did not change it. I did not split it apart. Now to go from the complete ionic to the net ionic, I cross out any spectators. That means anything that stays aqueous on both sides of the equation, so that would be your sodium. And your nitrate. And then you're going to rewrite exactly how you've written it before, anything that you did not cross out. So the final answer, the net ionic, is 2I minus aqueous. Reacts with lead aqueous to give you lead to iodide solid. All right, that's it.